and this flipcast is about three interrelated ideas: entropy, equilibria, and feedback. Entropy is about the tendency of everything to become increasingly disordered over time, a kind of chaos idea. Equilibria is the plural of the word equilibrium, which is about balance. And feedback is simply the mechanisms for taking a chaotic situation and bringing it back to equilibrium. Well, let's talk about entropy, increasing disorder. Ice melts, water flows downhill. If you leave a hot coffee on the side of the table, eventually it gets cold and becomes room temperature. Candles burn down. We're all going to die, and our bodies will eventually decompose. Our cars run out of gas and will stop going if we don't add gas. And I think if you even look at human affairs, if we don't put effort and energy and control mechanisms and management systems in place, things become increasingly disorganized and there will be chaos and anarchy. We can say that things will fall apart and the center will not hold. Here's a systems diagram to illustrate entropy. If we imagine time progressing like this, and over here we have an object that's highly organized, highly ordered, and as time progresses we can see in a kind of explosive way it's becoming more and more disordered, moving into chaos. And this could be the Big Bang, the entire universe, or it could just be a bomb or a firework exploding. Let's consider the candle on the left here. We know that a candle is essentially a lump of naphthalene wax, which is a hydrocarbon, like a fuel. And when that burns, the familiar products are carbon dioxide and water, and a great deal of heat. If you put your hand over the candle, you'll burn yourself if you get too close. But really, most of the heat is being lost into the air, and it dissipates. This is the word I'm going to write down. An important word. And dissipates means that it becomes useless for any further work. Notice on the right here, the burning is a lot more spectacular. A veritable explosion in this firework display in Honolulu. And it isn't just simple wax this time, it's complicated explosives featuring metals like magnesium, which burn white hot to give you that characteristic white firework light. And then also colours. You can imagine copper giving green and iron giving red colours. And with both the candle and the firework display, I hope you're beginning to realise that there's something irreversible about this. You can't unburn the candle. You can't repack the firework explosion. Referring back to this diagram, we can talk about an arrow of time, time moving in one direction. It cannot go backwards. It becomes one of the laws of the universe. We cannot unboil an egg. We cannot unfry an egg. Of course, eggs are a special case because as soon as you boil or fry an egg, you denature the proteins and change them irreversibly. And what about your room? What happens if you never clean it up? Every surface gets covered and you can't find a single thing. I'll show you a little bit of slow motion video, and I want you just to contemplate the entropy and the irreversible nature of time as you look at these objects doing spectacular things. Well, that was ice melting in reverse, but this one is my all-time favorite. It's a banana getting fresher. Well, the fact is that in nature things aren't constantly falling apart. And organisms and biospheres, ecosystems are often found in a state of balance or equilibrium. Let's draw you a little graphic about that. There's a scale representing a state of balance. Equivalent for equilibrium in organisms is a very interesting word, homeostasis. More about that in just a moment. The fact is that the biosphere is not falling apart. The level of oxygen in the atmosphere is approximately 21%. We know that the carbon dioxide level is a serious concern, but it is remaining at the moment at least at approximately 380 parts per million. If we turn to populations, we have already examined the idea of carrying capacity. After an initial explosive exponential phase of population growth, we can see that the population here is settling down, just hovering above and below the carrying capacity, the amount of population that the resources allow. Here's a graphic of the stable population of Denmark. You've got not much immigration, not much emigration. The birth rate and death rate are balanced out. The world population growth is a bit of a concern. We looked this week at the fact that we have now passed the 7 billion official mark. But we see that in the year 2050, things may be settling down, showing that the growth itself will be slowing down at 2050, reaching some kind of equilibrium. Let's take a look again.
The world will reach another milestone. Half of mankind will be living in countries or regions where fertility is at or below 2.1. That is the replacement rate at which a country is having only enough children to keep the population stable. It means population growth will slow down and give the world a bit more time to deal with its demographic and environmental problems. The current increase in population rise is the last that will happen in such a short space of time. The next billion will take slightly longer, about 14 years, and the billion after that, which raises the population to 9 billion, will take 20 to 25 years. By 2050, the momentum of population growth may have slowed almost to zero. It will be a more crowded, but more stable world.
And here's a very familiar graphic. Energy flow through the ecosystem, once again. You can see that the blue arrows represent the nutrients, and we can actually see a internal cycling of nutrients. But the energy shown in red is being lost at each stage. You can see we've got heat energy lost here, and here, and here. The reason that the biosphere doesn't actually run down into a state of entropy and chaos is that you've got this constant energy coming from the sun, replacing the energy that's lost, radiating from the earth. So feedback mechanisms bring a biological system back into a state of equilibrium. There's positive feedback and negative feedback. And negative feedback is the one we usually encounter, because that brings us back to the state of equilibrium. For example, body temperature in humans. The body temperature should be at 37 degrees centigrade. And you can see that if the body temperature rises above 37, then your body sweats, and that's a negative feedback. The sweating causes evaporation and the body temperature drops. Conversely, if your body temperature decreases, you may shiver to generate some heat, and that will bring you back up to 37 degrees centigrade. And both of these things are called negative feedback. Positive feedback is when things kind of spiral out of control, a vicious cycle of feedback. Here's a positive example from economics. If you have a bank account balance and you earn interest, your interest goes back into your original balance, so you earn even more interest. And then your balance is even bigger, your interest is even more, and so it goes in this positive spiral. Quite often though, positive feedback is a negative thing, and a runaway greenhouse effect, for example, on the planet Venus, is an example of positive feedback that went very, very badly wrong. Here's another example of positive feedback, another vicious cycle. So here we've got your sleep patterns interrupted, and that will increase your fatigue, and then your fatigue diminishes your ability to cope with stress. So the inability to cope with stress interrupts your sleep. So now we're back where we started with the messy kitchen. As time goes on, there's an increase of disorder, and that's entropy. But in biological systems, in organisms, and especially in ecosystems in the biosphere, we talk about a state of equilibrium, where things aren't getting more and more disordered. They're actually extremely organized and have a kind of set point of where they need to be. We looked at homeostasis and examples of negative feedback to bring you back to a state of internal constancy. So what would be the feedback, the negative feedback mechanism to get this kitchen back to normality? Well, the negative feedback would be clean the kitchen. A good metaphor for life, you may be thinking. Clean the kitchen, clean up after yourself and all that. A metaphor for saving the planet even. But let's leave it there for today. And as I always say, be careful out there and never ever stop thinking.